Hello, and welcome to my session, A Practical Guide to Test-Driven Development of Infrastructure Code. This session is part of an awesome community event called 90 Days of DevOps that is hosted by Michael Cade. You might be wondering, what is test-driven development? And what benefits can it bring me? If you're familiar with TDD as a practice, you might be thinking, is it really applicable to infrastructure as code? And if there's so, are there any things that I can reuse, any skills that I currently have as a DevOps engineer or infrastructure engineer, or do I need to learn a ton of new stuff? And lastly, what is the guy that is talking? So a little bit about me. This is me, or rather my necromancer in Diablo 4. If I don't play Diablo or any other game, I work as a cloud architect in DevOteam mCloud, Norway. Before that, I used to work for Microsoft for close to 7 years as a cloud solution architect. I really like to be active in various technical communities, meetups. I enjoy presenting at conferences like Nordic Infrastructure Conference in Oslo. And this session is actually a small downscale version of the original talk that I gave last year at NIC. I'm part of Azure Connections program and various communities, global communities like Azure Landing Zones, Azure Org, Bicep, and Terraform in Azure. If you want to reach out and connect with me, I have a very sort of single handle that I use across social media platform and other services like Sessionize and SpeakerDeck. I occasionally blog at my blog. So let's begin by explaining what is test-driven development. It is a software development practice where software requirements are being converted into a series of tests that you can run. And in the beginning, you write tests first. You don't write any functional code. And all your tests should fail, obviously, because you don't have any real code to back it with. Then you gradually start writing simple code to let the tests pass. And you just refine and refactor your code and improve it, while still rerunning the test, making sure that you're not introducing any regression and bugs into your code. So that's the principle. You might have seen this diagram or a different pyramid. It essentially shows you there are different types of tests. The biggest part is unit testing. You have integration tests, functional tests. You can have end-to-end testing. You can have user acceptance tests. So you have various kinds of tests, but they're mainly applied to software programming. But how about infrastructure as code? Well, there are some articles written on how these type of tests can relate to IAC practice. But in the end of the day, when I think about what I want my infra code to be like, is that, of course, I want this to be valid, to have a right syntax and follow some coding standards. It should also follow security best practices. So my resources should be configured in the right way. I should not really try to inject any secrets into my code in plain text. Ideally, I would like this infra code to be compliant with my target environment's policies and their overall governance. Because quite frankly, it is very frustrating if you try to deploy your solution and you get hit by a number of policies that simply prevent you to deploy your solution. And of course, you would like to follow your cloud provider's best practices. In case of Microsoft Azure, it would be a well-architected framework. And in the end of the day, of course, you would like to provision required resources to follow the functional requirements, what components you like, what properties they should have. The following diagram is my attempt to visualize what areas we have in testing or validation of our infrastructure code, what tools can be used, and I try to organize it in two main buckets, inner loop and outer loop. In inner loop, I believe it's a common understanding that you can run those tests locally even before you try to push your code to some remote branch or a remote upstream repository. What happens in the outer loop only in this diagram is tests that typically run only in your pipeline. You would not run them locally. So let's dive into individual categories. We have code validation, which essentially talks about, is my code valid? Will I hit any errors? The main hero here would be the linters, or you have a couple of different linters in Bicep. It's built-in Bicep linter. You can also think about Pester as a testing framework that is designed mainly for PowerShell, but you can use it also for Bicep. And there is an experimental feature that is native to Bicep as well, but this one has not been developed too much since it was introduced a couple of months ago. The second green box focuses on best practices. And here we will look into PS Rule, or PS Rule for Azure, which is a PowerShell module that helps you to assert your code against over 400 built-in rules that will help you to check whether your deployment will comply with recommendations from well-architected framework. There is also an older tool that was coming from the ARM JSON times, which is called ARM TTK, or ARM Test Toolkit. You can eventually use that too, but the Bicep core engineering team has an ambition to convert all those TTK rules into the native linter rules. The next big section is security testing, and here we have a number of tools we can use. In my presentation, I'm talking about Snyk and Kix, but there are others available too. The orange box is about that compliance against your target environment and what policies you can or you cannot hit. And here we will look into the powerful combination of using PS Rule with EPAC, or Enterprise Policy as Code, which is a separate project on GitHub. What happens in the outer loop only is you do deployment validation after you deploy. So you have something, some very natural tools to use, like deployment validate, where you just test whether target environment can actually deploy the code that you like, and it can help you with some validations, like is the target region that I'm deploying to, does it have enough resources in my subscription, so am I not breaching any limitations? Or is the service that I declared in my Bicep code actually available in the target region? Not all regions have the same scale of services. Then there is a what if, which is also very common. You try to compare the current state in Azure with what is declared in your code and see some kind of diff. And you can make a decision whether you want to push that deployment or not. And after you deploy, there are two tools that can help the actual validation of the resources that you deployed. One is called bench press, which is quite new tool, and Pester we've talked about earlier, but you can use Pester with PowerShell modules, to Azure PowerShell modules to actually assert against that target environment. That is why I believe it doesn't make sense to use those tools in the inner loop, but only in the outer loop. Now you might be thinking TDD requires you to write those tests first before you can actually write the functional code, in our case Bicep template or module. But is it really so? Do I need to use all those tools and write my own tests before I can use them? The reality is not that harsh. So in this table, I'm summarizing the tools that I am using in this talk, and the fact whether you need to write your own tests. You see only very few have the answer yes. Then whether there are some built-in tests you can just simply use to get the compliance and validation in the right shape. And then whether the tool can introduce some custom rules. This is mainly for those where you obviously don't need to write your own rules. Now, thinking about your coding environment, where you actually write your code, I think we can distinguish the local dev environment and a remote one. In the local, I'm using VS Code, as quite a big portion of the community do as well. And you basically have two options. Either you have all those tools installed locally, or you can leverage things like a dev container, which is a Docker container that can run and have all those tools baked in, so you don't need to install them directly on your machine. If you try to sort of move that a bit further and improve it, you don't actually need to install anything, and you can use GitHub Codespaces and leverage the same dev container configuration that you have in your repo to spin up that Codespace environment and have the tools available again, including the pipelines and everything else. The last option, Microsoft DevBox, is just a theoretical, just to have a sense of completeness, but we don't need to have a full-blown Windows environment to develop infrastructure code like Bicep or Terraform. So I don't think this is really applicable to our scenario. Now, if you think about all those tools and configuration options and prerequisites, it's can be quite overwhelming. And you probably have heard about Azure Landing Zone and the concept of an environment that has all the prerequisites, the required plumbing in place before you can deploy your solution or your workload into it. I like to think about it as a coding landing zone. So in order to standardize and decrease the overhead for thinking about all those tools and the configuration you need to have in your code repo, let's imagine that you can create a GitHub template repository that will have all those things baked in. Anything from a standard repo structure where you put your Bicep files, where you put your tests, where you put your documentation, where you put your configuration. Then you have your workflows folder where you have a standard set of folders for validation and deployment. And of course, ideally, if you're part of GitHub organization, you can use reusable workflows just to make sure that you can repeat the same patterns and have the same workflows running in multiple repositories. Of course, you can have configurations files predefined. It could be part of your organizational standard. Now I'm mainly talking about Bicep config.json, but there are other tools or other configuration files that you can use with the tools that we mentioned before. And then you have VS Code configuration. You can say that there are some recommended extensions that you would like to use together in your VS Code environment or in Codespaces. And if you wrap it all together, you can introduce a dev container in your template repo. So a user can spin it up easily locally if they have a Docker desktop, or they can use Codespaces just to get it up and running very quickly without even a need to have Docker installed locally. So let's dive into the first section, which is code validation. And as I said, Bicep Linter is a built-in tool for the Bicep CLI itself. It's very easy to install because you just install Bicep and it comes with it. You have a VS Code extension that is a must-have if you're coding in Visual Studio Code, because that gives you that language server and all the IntelliSense and all the linting capabilities that are built into the editor. So you don't need to run that validation in the command line, which you can still do, but it's much easier if you get that instant feedback in the editor rather than relying on some execution of the tool itself. But every time I'm mentioning a tool, I'm giving this table an overview, basically. How would you install the code extension? How would you install it locally as a tool? What is the execution? Is there any configuration file that you can use to influence how the tool behaves? And since we are on GitHub, is there a built-in GitHub action? Or if not, what would be the script or the code that you would run in order to trigger it? Now switching to a quick demo how the linting works. In this repo, there is only it's a very simple one. We have a main.bicep file, and we have bicep config.json, which is the configuration file that actually influences how the linter works and what kind of rules it checks or it doesn't check. So first of all, you have the enabled equals true, which you should have turned on. And then you can either have an empty list when it comes to the individual rules, or you can actually tweak if the compliance with the rule or in compliance with the rule gives you a warning or it gives an error. In this way, you can influence how that linter and the output of the linter behaves locally when you run the test locally, or how it behaves in your CI pipeline. Okay, so how does it look like in my Bicep file? As you can see, I intentionally created this very short Bicep configuration with a lot of errors or warnings. So you can see that those squigglies, either yellow ones or red ones, depending if I configure them to be warnings or errors, are giving me hints. And the good thing is that every time I'm breaking some rule, there is a link to a page which explains me what is wrong and why should I reconsider changing this configuration to something else. And you see that I have also an error because I'm essentially using something that is not declared. So if I try to run, or I can also just use build on template, which is the process that will tell me if my Bicep configuration is correct. I can see that there is a lot of the same errors that I see in the editor are surfacing here. And as you can see, I don't have any main.json file because due to those errors, my compilation to ARM JSON didn't happen. The next tool up is Bicep Native Testing Framework, and this one was introduced in the Bicep Global Community Call, I don't know, was it 6 months already ago? But the truth is there hasn't been too much of a development, and I think it is a shame because it can really empower you to write your own tests that are native to Bicep. And the idea is that this framework introduces a new keywords like assert and test, so you'll be able to validate that directly without deploying anything or using a third-party tool like we are introducing here. So since there is not much to share apart from an idea, and it's an experimental feature, you can try it yourself, but there is not much support for having it or consider it in real production. Now let's move on to best practices validation. We are talking about validation against well-architected framework, recommendations and rules. Our main hero tool here is PS Rule for Azure. PS Rule is a generic engine, but it has an extension just for Azure. It has some other extensions as well. And in its core, it's just a collection of modules. So you need to have a PS Rule module from the gallery and a PS Rule.rules.azure module, which contains over 400 predefined rules or tests that you can use. So you actually don't need to write your own tests, but that capability is also available, and you can run them in write them in three different formats. It's either native PowerShell, or it's YAML or JSON. And there is a very extensive documentation available that can guide you on how to write your own tests. But for our purpose, we just want to run those 400 plus tests in a bulk. You can also be quite selective, so there is a lot of customization that you can use with PS Rule for Azure. But you just want to have that modules installed and use assert PS Rule. You provide input path, and it can and the input path of course contains the Bicep files. As an output, there are many formats, including Serif, which is quite useful. And you can also integrate easily with Azure Monitor Workspace. So all the runs of those tests can be surfaced in your workspace, and you can query them using KQL. So this table gives you an overview on how to install VS Code extension for PS rule, how to install the modules locally from the PowerShell gallery, how to execute those tests using assert PS rule commandlet, mentioning psrule.yaml, which is a configuration file you can use to tweak the behavior of PS rule, and the fact that there is a built-in GitHub action that you can leverage instead of running the raw PowerShell commandlets in your pipeline. So let's quickly jump into VS Code, and here this is a slightly different structure than I had in the previous demo. So we have modules with the 2 modules and the one that is for storage account, which is very easy to create. And in order for PS rule to work properly, it's recommended that you create .tests subfolder with test.bicep. That's just a naming convention. It's a Bicep file that only calls that module that you declared, and you inject parameter values. So you will be actually testing not the raw module file, but the test.bicep file with those values. In the root of your repo, you can have psrule.yaml file, which you can use to tweak things like ignore paths. Very important parameters are file expansions for Bicep file and parameter files, which you want to use. It's worth noting that this tool existed even before Bicep was a thing, so it was very useful for asserting against raw ARM.json templates. And if we want to run it, just give me a second. Yes. Summary. So as you can see, I have 23 rules were processed and 1 rule failed. And if we look at the details, it tells me that block public access should have a different configuration. And if I look at the configuration here, it basically shows me that it is not configured, or the configuration is allow block public access, which is not recommended. The nice thing about PS rules is that it also gives you a link to a documentation. So if you open that file, it gives you a page where it explains you why this rule exists, what is the recommended practice, and also how you can fix either your ARM template or your Bicep file to comply with that rule or recommendation. Now let's switch gears to security testing. As I mentioned in the overview, there is a number of tools you can use, but I wanted to demonstrate Snyk, which is a quite well-known brand in the security community. And they introduced a way how you can test your infrastructure code. And they support, of course, a number of formats, including ARM templates. So the support for our Bicep scenario is a bit indirect. You need to transpile your Bicep template into an ARM template, and then you can test that against the rules coming from the Snyk cloud. So in order to use this tool, you need to install it, and you need to get a free account in snyk.io. But after that, you can use it from the command line as any other tool. There is also a free VS Code extension available. You can try it out. For the local installation, since I'm on a Mac, I'm using Homebrew to install it. And then you need 2 commands in order to execute this locally. It's a Snyk auth. It redirects to a browser where you can authenticate to your Snyk organization. And then you run a Snyk IEC test, and you provide a path to your transpiled ARM template. There is also a GitHub action that is built in, so it can make your robust testing in your CI/CD pipeline much easier. So let's switch to VS Code. I have the tool installed, so if I want to do sneak auth, it will redirect me to my organization. I'm authenticated. So now I will just run an ISC test against deploy.json file. And as you can see, it hasn't found any issues. So my test or my template is written correctly. And if you have the extension installed, you can get some inline recommendations when you're opening your JSON template. Next up is a compliance validation. So here we are talking about how can I make sure that my deployment declared in Bicep can actually succeed when I try to deploy it from the command line or through the pipeline. Doesn't matter. And there is a number of policies and other guardrails that my organization can set up for me, and it's very difficult to really know what policies will apply to my context, my subscription landing zone, my resource group, etc. So until recently, it's been available for a couple of months now, but for a long time there wasn't really a good way how you can test your infrastructure code in Azure against the policies, because there was no way how you can bring that policy engine locally. But thanks to a combination of two great tools, PS Rules for Azure, we mentioned already, and a second one, which is EPAC, or Enterprise Policy as Code, we can actually achieve that. So the way it works is quite simple. We install both or all three, to be specific, PowerShell modules, and then we run specific series of commands that will allow us to look into our real environment in Azure, export all those policies that were applied in the environment that I'm targeting, convert them into a format that PS Rule can understand, and then I will assert PS Rule, use the same command that I used before to validate my code against WAF recommendations, and I will target only the rules that were exported through the EPAC module. Sounds cool, doesn't it? So if we switch to VS Code, you can see that I already ran those commands. So first I ran the export AZ policy resources, which gave me this PS Rule assignment JSON. It's a long JSON file. Then I ran a second command which converts that output from the first command into the object JSON-C file under PS Rule.ps rule. And then I can simply run using assert PS Rule. And as you can see, I did it already. And all those warnings and errors are only coming from Azure.policy. And the way I achieve that is that I have a psrule.yaml in the root folder, where I'm only saying that it should include the Azure.policy star rules. It should not really assert against WAF rules, those 400 plus, but only for the rules that were part of this export. Okay, so I could easily look into the output. I can see that, for instance, that some of the rules is telling me that I'm not compliant when it comes to a location. I believe one was about that. So I'm trying to deploy to a region where I'm restricted to deploy to. So I can easily fix those and try to rerun the tests, and then I can be quite confident that my deployment will succeed. Okay, so far we've been talking about how you can use those various tools to run those tests locally which is great, and you should actually do that. You should run those tests before you commit the code and push it to your upstream. But what if you feel you're good, you're done? Of course, you need a proof to your colleagues and reviewers mainly that your code is secure, compliant, follows the best practices, etc. So the same set of tests you would like to run in your CI/CD pipeline. So, of course, since we are using GitHub as an example, we will be looking into a workflow that actually combines all those tools and binds them together. So, looking at the infra deployment YAML file, as you can see, I'm declaring a number of jobs. One is a simple linting, which is nothing more than just running az bicep build. Then we have validation, which is using a pre-flight validation as a specific parameter for the arm deploy action. The next one is PS rule. I also mentioned that there is a built-in action for that, so you don't need to do much more than just provide specific inputs to what modules, of course, you want to assert against, which is the rules of Azure, the input path, the output format, and how the output file should be named, which is very useful because then you can use, for instance, this action to publish the result of that unit test into your pipeline run. The next one is sneak, so you can run the same security test that you did locally. All you need is to provide a sneak token that you can get from sneak.io from your organizational account. You can provide it as a GitHub secret, and then you can get the same results that you would get locally. But you can upload those results using GitHub's built-in function or action to upload Sarif files. Preview is quite known, so you are running what if, essentially, trying to test what is the real environment, how does it look like, and how does it compare to the code that you are now trying to deploy. And then there is the actual deployment. As you can see, I'm using the environment, so the deployment itself would be paused before I actually execute or approve that the deployment can happen, which is a good practice because if I'm getting all those test results, I should, as a human who is making the final call, I should have a time to approve them. Of course, this is not really aligned with an idea of continuous deployment, but in many cases this is being used as a step to ensure that it is safe to push that deploy button and deploy changes to the environment. This section we haven't talked about, but after you deploy, there is a way how you can test the actual deployment. So did it deploy what I intended to? And there are a few tools you can use. One which is called Benchpress, which is another PowerShell module which builds on top of Pester. And the other one is Pester itself, because you can leverage AZ PowerShell modules to basically call those actually deployed resources and assert against properties of those resources if the deployment succeeded, and if those resources like storage account have the right properties as you declared. So you can run those tests also as part of your pipeline. And the last type of test that is also mentioned is that you can run infrastructure test. In this case, it's called smoke test. So I'm deploying a website. So I can grab an output from the deployment, which is a URL of my new web app, and I can assert against certain tests that I have here in Pester. Now to wrap things up. Installing and configuring all those amazing tools to help you on your journey to have a valid, secure and compliant infrastructure code can be a bit daunting or overwhelming. Wouldn't it be great if you can get that pre-configured and pre-installed everything in one environment? So remember when we talked about the idea of coding landing zone, I mentioned the dev container. So if you're not familiar with the idea, you can go to VS Code documentation and read more about that. But essentially, you declare how that container should look like, what properties it should have, what tools you want to have installed locally, and then you don't need to do anything except making some small configuration tweaks. So let's look into VS Code on how this could look like. So we have a .dev container folder in our repo where we have dev container.json file, which is the main configuration. And of course, I'm using something that was pre-created before. But essentially you have, in this JSON, you have a couple of sections. One is features, where you are allowed to say what tools do you want to get installed, pre-installed in that container, which is Git, GitHub CLI, PowerShell, Azure CLI, Sneak CLI, so all those nice things. Then you have a section where you customize your VS Code experience to get some extensions automatically. And these are essentially all the extensions that I mentioned earlier. And you can tweak some settings, how your integrated terminal VS Code behaves, and importantly, what should run when you try to build that container. And there is a link to both the Docker file, which is just a reference to Microsoft Container Registry and some quite lean dev container. But here in that container build PowerShell script, you can see that we are trying to install all those PowerShell modules from the gallery that we need in order to run Pester, PS rules, etc. So you can see all those modules here, and of course Azure PS modules. So all that can actually result in you having that dev container available either locally, and if you have a Docker desktop, so you can run that environment locally in your as a container, or you can spin up a GitHub Codespace environment where everything that we have and we need in order to start developing our Bicep modules and templates will be baked in. That's all for today. Thank you for watching my session. If you're interested in more details, you can check that on my GitHub account or speaker deck. I would also like to thank Michael for the opportunity to be part of this great event, and I would encourage you to check this page for more great content. Bye.